All right, welcome. Today we're skipping the theory and getting right into the action. We're going to take a totally standard, fresh out-of-the-box K3s installation, the kind you'd spin up for a quick test, and we are going to forge it step by step into a rock-solid production-grade citadel. This is the hardening journey.
Every big, complex cluster has to start somewhere. And for us, it starts right here, a single, freshly installed K3s node. It's basically a blank canvas, which is awesome. But as we're about to find out, that canvas is also covered in risks right from the word go.
So this is our ground zero. Look, one of the best things about K3s is how ridiculously easy it is to get up and running. But, and this is a big but, that convenience comes with a trade-off. By default, its internal network is a free-for-all, and its most powerful credentials are way too easy to find.
So here's the bottom line. When you first install K3s, it's built for speed and simplicity, not for airtight security. Thanks to the default network setup, every single pod can chat with every other pod across the entire cluster. And that, right there, is our first major mission. We gotta build some walls.
Think of your cluster like a brand new office building. In its default state, it's just one giant open-plan floor. Everybody can see and talk to everybody else. From a security point of view, that's a nightmare. A breach in one little, unimportant app could spread like wildfire and take down the whole system.
And this slide right here shows you the complete transformation. We use a totally standard Kubernetes tool called network policies. We slap on a default deny policy and boom, it's like we've put every single application into its own private locked room. Nothing gets in or out unless we specifically create a key for it.
And what I love about this is that it's not some big, scary, all-at-once change. We can be really methodical. As you can see, we just go namespace by namespace. We start with the important stuff, our DNS, observability, and we just work our way down the list, locking things down until the entire cluster is secure.
Okay, so we've put up the internal walls. Now we have to protect the whole thing from the outside world. We need to secure the cluster's administrative brain, the control plane. This is like putting a massive reinforced lock on the main gates of our citadel.
This is a fun one. What do you think is the single most powerful file on your whole server? It's not the main K3s program itself. No, it's actually a simple little YAML file, a text file that gives you complete, godlike administrative control over everything. And by default, it's just sitting there.
But check this out. With literally one line of configuration and a quick service restart, we can tell K3s to just not write that file anymore, ever. It's such a simple, elegant fix that makes those super powerful credentials disappear from the file system, and that just shrinks our attack surface dramatically.
Now, this is probably one of the biggest misunderstandings in the Kubernetes world. People see that jumble of letters and numbers in a secret and think it's encrypted. It's not. Base 64 is just encoding. It's not scrambling anything. Anyone who can read the database can easily decode your secrets. We have to turn on real encryption.
And the great news is K3s makes this incredibly easy. You just add one little flag, -secrets encryption, when you first install the server, and that's it. K3s handles the rest. It creates an encryption key and makes sure all your secrets are properly protected. It's a huge security win for almost zero effort.
Okay, now we get to the really cool part. We've built our walls, we've locked the main gates. Now we're going to write a constitution for our cluster, a set of laws that cannot be broken. And we're going to hire a robotic police officer named Kyverno to patrol the streets and make sure absolutely everyone follows the rules.
Our first law is super simple, but so important. It basically says, no application is allowed to just open up a door to the internet. This policy completely blocks services from creating a node port or a load balancer by default. The only thing allowed to talk to the outside world is our trusted ingress controller, which we've put on a special list.
And law number 2 closes a really nasty backdoor. A host path volume is dangerous because it lets a container reach outside of its little box and touch the server's own file system. By banning this, we make sure our containers stay in their digital sandboxes. It prevents a container jailbreak that could take over the whole machine.
But here's the thing about security. It's not a one-and-done checklist. It's a constant process. You have to keep watching, keep tweaking. And it was that constant observation that led us to our next big problem, a crisis that was brewing from the inside out.
This number just started screaming at us from our dashboards, 92%. CPU usage was pegged, and the cluster was about to fall over. But when we looked closer, it wasn't an attack. It wasn't a virus. The threat was one of our own tools. And the culprit was Longhorn. Now don't get me wrong, Longhorn is an amazing piece of technology for a big multi-node cluster. But on our little single-node setup, all of its powerful replication features were doing absolutely nothing except chewing up a ton of CPU and memory. It's the perfect example of having the right tool for the wrong job.
So what does all this mean? Well, we've successfully hardened the cluster against threats. That's a huge win, but the journey's not over. Now the new mission is to make the system not just secure, but also stable and efficient for the long haul. And that means tackling this resource problem head-on.
And really, that's what this is all about. A truly great system isn't one that never has problems. It's one that, when things do go wrong, gives you the insight and the clarity to know exactly what's happening and why. That deep understanding, that's the real sign of a production-ready cluster.